If I was just to simplify this down, and I was just to imagine I had a piece of metal which was 10 meters long, and I was to think, how would I work out the weight of that? Now it's 1.5 kilograms per meter, so every one of these meters is going to weigh 1.5 kilograms. Then I'm basically going to times this length by this, and I'm going to get 15 kilograms. So that's a quick outline of what our plan is going to be. We're going to find the total length of all of these, and then we're going to times that by 1.5. Now be careful not to miss this length in the middle. And to work this out, we have to use some trigonometry here. It's part of a triangle, so it's a right angle triangle as well. We can use Pythagoras. Now I'm going to put this all into one calculation rather than doing it as lots of individual calculations. It's a bit of a preference for me. Makes it a bit quicker and also forces you to work backwards because you have to work right from the plan you have at the start and start to fill in what you don't know. So I'm going to times everything by 1.5. I know that straight away. And now I just want to work out what the length is. So this length here, that's 12 meters. So is that one. So we have two lots of 12 so far. Then this length and that length. So counted for all the outer edges now, we've got two lots of 5. So I'm just going to add two lots of 12, two lots of 5, that tells us the area so far. But now I want to work out this in the middle. And I can use my trigonometry for this. I can use Pythagoras. Now Pythagoras' theorem states that a squared plus b squared is equal to c squared, where c is the longest side. I'm going to rearrange this and make c the subject, so I can simply square root both sides. I'd recommend doing the algebra first before putting the numbers in. It's quite an intuitive technique which helps, especially as you get more advanced in mathematics. So now all I need to add to here is the square root of 12 squared plus 5 squared. Now I'm going to do a bit of mental maths here rather than writing it all out. So 2 times 12, that's 24. Add 2 times 5, now that's 10. So I'm going to add 10 to 24 and I get 34. 12 squared, that's 144. Add 5 squared, that's 25. In total that gives me 169. Now you might not know the square root of 169 offhand. It's just beyond the times tables. We have 144, that's 12 squared. 169 isn't too much further after that, so it's probably going to be 13 or 14 squared. And it ends in a 9. That means it must be something ending in a 3 squared. It must be 13. So the square root of 169 is 13. And I'm just going to add both of those together. So 34, add 13. If I add the 3 first, I get 37. If I add the 10, I get 47. So now I want to do the calculation of 1.5 times by 47. We could follow a similar method to what we did before with the multiplication and do 15 times this if we wanted to. But there's a slightly shorter method we can do, and that's we can consider that this is 1.5. So we're essentially going to have one lot of 47, add half of 47. Half of 47 is, well, 46, that's the nearest even number, and that's 23. We've got to add another 0.5 to that in order to double that and give us another whole number. So it must be 23.5. Adding both of those together, if I add the 0.5 to begin with, that's 47.5. Add the 3, I get 50.5. Then I add the 20, I get 70.5.